is statistics, and finally scatter plots and researches, which is one of the topics on which it is hard to come across good material or good content. As in all, I mean, this has the largest syllabus of all the 4 areas that we usually talk about at the SAT. One key thing that you need to observe is that questions from this unit can happen on section 4 only, which means you'll always be permitted to use a calculator when you solve this, right? So I think I talked about it earlier also, that any attempt to learn those speed calculations or fast calculations or Vedic math are absolutely unnecessary for this test that we call as the SAT. Out here, whatever stuff is calculation based, you'll always find them on a section where calculator is allowed. On section 3, normally there'll be simpler calculations that you can easily do manually. All right, so with that, the second thing that all of you need to know here is, is to how to use a graphing calculator. I've seen lots of students getting into the SAT with a simple scientific calculator. Sorry. Lots of tutors advising the same, but you see, you're permitted to use technology here. Please make sure that you get yourselves well versed with the scientific calculator, the graphing calculator, and you carry it to the test date. It is permitted. The 2 calculator models that I recommend here are the Casio. So an excellent calculator is a Casio FX-CG50. If you're looking for a cheaper version, you may use a Casio FX9860. Any calculator of this series. Then you have the other ones from Texas Instruments. The one which is common in use is the TI Inspire, but please know that this is an amazingly complicated machine. So do not start with it unless you are using the same at school, right? If you're not using a graphing calculator at school, you got to learn it from scratch. Please go ahead with the Casio calculator only, which is going to be far easier to use and operate. The second question, how do I get to use or get to learn these graphing calculators? Because I've not seen anything so complicated ever, right? So on this calculator, you can graph stuff out, you can solve statistics problems, you can solve a whole lot of stuff. You can solve the circle equation. I mean, there's so many things that you can do. So, I mean, it's just not difficult as to how to learn this calculator. And you have the best tutor in YouTube available with you. So whenever, you want to learn something, how to do it, beyond some basic guides, you can simply Google or simply go onto YouTube and search, how do I calculate standard deviation on a Casio FX-CG50, for example. It'll throw up a 90-second video for you or 2-minute video for you. And you just run that video twice over and you'll be very well versed with how to do that. Okay, so with that backdrop, I think let's start discussing the topics for the day. And I'll be basically talking about scope and some of the important things that you bear in mind with the kind of time that is available to us. A comprehensive detailed tutorial is not possible. Also, before I start this, let me remind you that the registrations for the scholarship test are now open. The scholarship tests are scheduled for 30th and 31st of January. We'll be posting results by about 10th of February on the Next Genius website. So if you're not registered for these already, please go ahead and register right away. You could end up winning phenomenal scholarships. Lots of people have asked me, that what do I practice for the scholarship test? Nothing specific, it's a simple test of math and English. So I want you to take it in the spirit of taking as a diagnostic test as well. Still, if you want to practice, you can go to Khan Academy and do a couple of SAT practice papers from there. Also, we have 2 scholarship tests, one for The SAT and the one for the ACT, I'll very strongly recommend that you take both the scholarship tests and not just one of them. All right, let's go now. Let's talk about arithmetic. So the first topic that you need to apprise yourselves in arithmetic is percentage. And a second one is ratio. And then there could also be questions on time and work, time and distance. These are some of, not that frequent. You'll find them here off and on. Off and on, you'll also find the odd question on mixtures that tends to be tricky. Right. So, percentage. You'll have to come out of the traditional way of studying percentages. What you got to learn out here is a percentage ratio equivalence. That will come very, very handy on this test. As in, whether I call a number 50% or I call it 1/2 or I call it 0.5, these three things are to be used interchangeably, right? Increasing a number by 20% or multiplying it by 1.2 would always have the same result. I think I would prefer this method always over the other one where you increase a number by 20%. So this is a concept that we call as multiplying factors. Please understand, using multiplying factors, all percentage changes can be converted to ratio multiples and all ratio multiples can be converted to percentage changes. Just to give you an example, if I increase the number by 17%, I would not want to calculate the 17% of that number and add to it. I would simply prefer multiplying by number by 1.17, right? And they work on both sides. So if a number had to decrease by 20%, the equivalent multiplying factor would be 0.8, right? Which we get, let's say x minus 0.2x is equal to 0.8x. So whether I calculate 20% of that number and subtract from it, or I multiply it by 0.8 is going to have one and the same thing. On the other hand, if someone tells me that a number has become 1.44 times of itself, I can say as well that the number has increased by 44%, right? On the SAT, you normally find two types of questions, one which are related to percentage change calculations, and the other which are related to variation. The one which are related to percentage change calculations are normally made a bit tricky by calculating them in reverse. For example, if I say the price of tomatoes increases by 20% to rupees 60, what was the original price of tomatoes? Most of us, would tend to calculate 20% of 60 and then subtract it from 60 to get 48 as the answer, which is incorrect. The correct way is that you assume the original price of tomatoes to be P, and they say increasing by 20% means a multiplying factor of 1.2, and 1.2P gives me 60. So P would be 60 upon 1.2, that will give you 50, right? Please take care of this. This is one mistake I've seen so many students making so often on this test. The second stuff is related to, ratios. So or variation. I'll give you a tricky example here. So I say I have a cylinder. All of us know a cylinder. And they say radius of the cylinder increases by 10%. And its height increases by 20%. By what percentage does its volume change? Now, a question like this, how do we attack it usually? I would say the volume of a cylinder is pi r squared h, right? I'll take initial values of r. Let me take r equals 10, h equals 10. And I calculate initial volume as 1000 pi. When I increase r by 10, it becomes 11 and this becomes 12. And I put in these values and I calculate the volume again, and then I calculate percentage change. This is all nonsense to me. This is unnecessarily complicating your question. How do we do it? So here, please understand that pi is a constant. So pi is not going to change. It would not participate in any of your variation calculations. The radius increasing by 10%, means the radius becoming 1.1 times, and this is squared, and height becoming 1.2 times. When I calculate this in my calculator, I am going to get 1.452. So it tells me that my volume becomes 1.452 times. And when it has become 1.452 times, to me, this has increased by 45.2%. Simple. Okay, it's a long session today. I'll have to be brisk with what I discussed with you all. So that's arithmetic. Ratios, you'll normally find simple problems. Mixtures, you'll need some practice. Mixture questions can be tricky, right? Let me say, for example, I have a 20% HCl solution, which is 4 liters. Well, how much water should I add so that this becomes a 10% solution? So how do you go about doing it? Just calculate HCl in this thing as 0.8 liters, which is 20% of 4. And then for this to become 10 liters, so 0.8 upon x should be equal to 0.1. When we solve this, we'll get x equals 8 liters. So 8 liters is the final value of solution required. I'll be required to add 4 liters. That's going to be a correct answer. Okay, moving on to, I think, linear and exponential growth. So fundamentally, the difference between linear and exponential growth is the difference between simple and compound interest. So let's say I start with 1,000 rupees and a 10% rate of interest. And what happens in case of simple interest is that only the principal begets interest. So each year, your amount is going to increase by the same fixed quantity. So if I start with 1,000, in the first year, I'm going to earn 100 rupees as interest, second year, 100, third year, 100, fourth year, 100. So this can be expressed by the simple formula 100x, where x is the number of years. And if I draw a graph, I'm going to get a constant straight line, constant slope straight line, with slope as 100 and y-intercept as 1,000. So anything that grows like this, I call it as linear growth. Compound interest, on the other hand, what happens? Periodically, the interest earned is added back to your principal and it becomes eligible for earning further interest. So starting with 1,000, first year I earn 100. I'm left with 1,100 for the next year. This is the amount that will be earning interest. 110 is the interest earned now. Now I get 1210 in my kitty, so I earn 121 as interest, 1331, and so on and so forth. If I draw a graph in this case, this is going to look like this. This is something we call as exponential growth. Right? Now you need to learn the exponential growth formula very well. So supposing I start with 1,000 rupees and my rate of interest is 15%. 15% rate of interest means what? At the end of first year, my money is going to increase by 15%, or it would become 1.15 times of the original value. So at the end of 1 year, this will become into 1.15 times. At the end of second year, this whole thing will become 1.15 times. Third year, this whole thing 1.15. So this, if I collate, I'm going to get 1,000 into 1.15 to the power x. Now, interesting possibilities develop in this, when you change the period. So I'm not discussing that, but you'll find a good treatise on Khan Academy. But those are the tricky problems that you can face here. For example, I say I deposit 20,000 rupees to a bank that pays 30% per annum and compounds 6 monthly and not annually. Now, how would I express this? If this was annual compounding, this would have looked like this. But when I say 6 monthly compounding, in 6 years, I'm not going to earn 30%. In 6 years, I'm going to earn 6 months, I'm going to earn 15% only. But In X years, now I'll be compounding it twice. So because every year I'm compounding it twice, in X years, I end up compounding it 2x times. So that is what it will look like. A third topic that I take up here is statistics. I'll come back if I have more time. I'll come back to time and work and time and distance as well. Statistics, you need to know the mean, how to calculate. More importantly, you need to know the median. And you need to know the difference in these two cases. When do we use the median? When do we use the mean? And why do we prefer the median over the mean? Because median is not impacted substantially by outliers. Mean, if you add one big value, it will distort the mean of the entire group. So mean, one thing that you got to remember is that before you start calculating median, you must arrange the data in order, either ascending or descending, and then look for the middle term. If there are two middle terms, you'll have to take their arithmetic average so as to arrive at the median. My very strong recommendation here is that, whenever you have got a question on statistics, and if it can be solved on the graphing calculator, you must always solve it on the graphing calculator. Never try to solve it manually. Even if it's a very simple, very stupid problem, and it is a problem which can be solved on the calculator, do solve it on the calculator. I've seen students making lots and lots and lots of mistakes on statistics, which are simple, pure calculation errors, which can easily be avoided. For example, if I had to calculate the median manually, I'm required to put my data in ascending order. But if I'm required to calculate the median on the calculator, whatever order you punch it in, it will be able to give you that median. Okay, moving on. So sorry. One topic that I'm going to cover here in detail in standard deviation. You'll often find questions on standard deviation on the SAT. Now, please know that you're not required to know the standard deviation formula. So let's see what is standard deviation. Most of you would not have covered standard deviation as a part of your school curriculum till now. So let me start with a very simple example. I'm teaching 3 batches for the SAT right now. And there are 5 students in each batch. For the first batch, the scores of these 5 students in a test that I conducted are like this. And if I ask you what is the mean of these 5 students, simple, 60. Median of these 5 students, that is also 60, fair enough. My second batch, these scores are 58, 59, 60, 61, 62. What is the mean now? You don't have to calculate, please know. It's a symmetric series. Can you see that? For a symmetric series, the middle term will give you the mean as well as the median. So the mean is 60 and the median is 60. The third batch, the scores are 40, 50, 60, 70, and 80. What is the mean now, guys? It's still 60. And the median, that's 60 as well. One of my students comes to me and asks me, hey, Abhinav, how are your 3 batches doing? I said, they're doing well. No, as in, how are they faring? I said, ask me a few questions. They asked me, what is the mean of these 3 batches? I say the mean is 60 each. And the median is also 60 each. Wow, then the 3 batches must be identical. Are they? No, they are not. Which means, apart from calculating a value, which is a central value for my data, I'll also have to study like how these values are spread around a central value or dispersion. Can you see in the first case, all values are identical to my central value? In this case, my dispersion is 0. In the second case, I have some dispersion. So I'll say the values vary. Yes, somewhat. And the third case, a lot. Unfortunately, these words, somewhat, lot, they don't have a place in mathematics. We need concrete measures. We need numeric measures. And the best way to measure dispersion, one crude way is range. Range, of course, we know is the highest value minus the smallest value. But a much better way is, standard deviation. Right? So standard deviation would be 0 when all values are identical. The more the values are spread apart from the central value, the standard deviation is going to be higher. I'll just give you one example here. So this is my mean, and I have some values here spread out. What I could do is I could calculate deviation of each of these from the mean and add them, but that will only get 0. Because positive and negative deviations will cancel out. So what I do is, for each individual value, I calculate the deviation from the mean and square it. That way, all negative and positive numbers would be converted to positive. And then I sum these deviations and divide them by the number of observations and finally take a square root. This is sigma or standard deviation. You do not need to know this formula on the SAT, just need to understand standard deviation conceptually. Also, in situations where you have to solve a question on standard deviation, please know that your graphing calculator can very easily calculate standard deviation for you. Fair? Okay, let's move on. One dicey topic that you need to go through here is researches and scatter plots. Okay, what's a scatter plot? Let me give you an example. So the principal at your school is interested in knowing how she can improve the SAT scores of her students. And she invites an outside consultant, to help her out with this. And the consultant studies the SAT scores of students against some 20, 30 different variables. And she says they are most significantly correlated with the student's weight, or let's say height. So for a sample of 20 students, she plots the data. Such a plot, we call it as a scatter plot, right? I can draw a trend line using some mathematical tools. This line I call as line of best fit. This is what a scatter plot and line of best fit are. Now, ordinarily, you'll get what? You'll get questions about interpretation of this line of best fit. For example, they may ask you, if the line of best fit has a y-intercept of 970, what does it mean? It means hypothetically the SAT score of a student with 0 weight. Even if that was nonsense, but that is what it would mean. They may ask you, what do I mean by the slope of this line of best fit? We understood in the last class that slope is increase in y when x is incremented by 1. So you have to see in what unit is the height given here. So slope here would mean the expected increase in height of a student's SAT score of a student when height is increased by 1 inch, right? So this is all simple stuff. Beyond that, you have at times questions on sampling. So whenever there are questions on sampling, you've got to take into consideration that for a good sample, it must be representative and it must be random, as in it should be unbiased. As a very simple example, if I say, I was doing a research on what percentage of working executives in a South Delhi market or in a South Delhi area prefer a pizza for lunch. And I go to a Subway and take a sample from here. Is this sample going to be relevant? Absolutely not. It's going to be biased. Okay, I take a sample from Pizza Hut. Even that would be biased. So I should rather take my sample from a place where food choices would not come into picture. For example, the parking lot of an office, right? So I'll be able to get a random sample that way. So this is what you find questions on, lots of them. You'll also find questions on causation and correlation, which again is a tricky topic. But this in roughly, represents the general landscape of problem solving and data analysis. There are questions also here on probability tables, two-way tables, simple probability questions. You do not know or need to know probability concepts in depth. It'll be simple calculation, but you'll need to know how do I read the probability tables, the two-way tables especially. So some practice with a few of those questions will get you there. It is not very difficult. It's not very difficult. That's about what you have, on this particular section. The odd question on time and work, I'll take one more example here. It says A completes a work in 20 days. Let's say 30 days. And B completes a work in 60 days. If they start working at it together, how many days will they take to complete the work? I cannot add these times. I cannot divide them. I cannot subtract them. All I know is that this answer is going to be less than 30 days, because when A alone is completing the work in 30 days, with the help from B, he'll be able to finish it off in less than 30 days, correct? So what we do is we assume the total work. Let's say my total work to be done is 60 units and A is completing it in 30 days, which means every day A does 2 units of work. Simply, I can find that every day B does 1 unit of work. So when I say A plus B, every day they would be able to complete 3 units of work, and they have to do how much? They have to do 60. So how much time will they take? They're going to take 20 days. For this type of questions, guys, I would suggest please do not remember any fancy formulas. Just go by the first principles. I've always believed that SAT math is best tackled when it is done with first principles and not with fancy formulas. In most cases, when you end up cramming formulas, the questions would be framed in such a manner that you'll end up getting them incorrect. So I think that's about what I had to talk about. Later in the day, we have multiple sessions. We have another session on SAT writing, another one on SAT reading, and then we have 2 sessions on SAT math and 1 session on ACT English. So we'll be chock-a-block continuing right until 8 o'clock. Let me see if we have a few questions here. I would love to take them on.
That was really so got to know got to go through the whole arithmetic in such a quick way. The multiplying factor theory in the percentages and all those stuff in the compound interest, how exactly that the same multiplying factor could be implemented, and also the gist of statistics. So it was really a great session. Thanks a lot. I would like to take you through some questions, sir.
Yeah.
So is 1380 a good baseline score with zero preparation?
Oh yes, it is an excellent score with zero preparation. Do take the scholarship test. Yeah.
Okay. So how can we get 100% scholarship?
There's 100% scholarship available for SAT, 100% scholarship available for ACT. So if you get the highest score, you'll get it.
Okay. Sir, I have a TI 84CE plus. Is that allowed?
TI 84, all models are allowed.
Okay. Will the scholarship test be kind of mock SAT?
Yes, it will be kind of.
Okay. So are the college board practice tests advisable?
Yeah, you can practice with the college board practice test, because the test that will be giving you will not be one of college board tests. It will be one of our own tests.
Can the student carry a sheet for calculation, for the rough calculation in the ACT?
Yes, you can do. I mean, a career in the ACT rough sheet is allowed.
Okay. And okay, so a few questions related to the context, like what if there are even number of observation in the example what you took of 40, 50, 60?
There'll be 2 middle terms. You take the average of them. For example, if there are 8 values, then your middle term are 4th and 5th term. You have to take their average. So
Okay.
for 40, 50, 60, 70, 80, 90, the median would be 65, which is the average of 60 and 70. This is not
Okay.
related to any specific grade. It is general math. I mean, so multiple grades constitute.
Sir,
Calculator
any
name
advice?
FXCG50. You can go back to this session on YouTube and watch that session. On FX CG9860, Casio FX9860 G2.
Sir, any specific advices for the scholarship test?
Oh, no, nothing at all. Just be yourselves. Quite a few questions. Class 9, should I prepare for NTSC? And prepare for NTSC right now. SAT you can prepare later on. SAT is mostly a multiple choice type question. There are some, gradient problems here. I think I discussed that. 1300 is a good raw score. Any score above 1200 is a good raw score, honestly, if you've not done any prep for it.
Okay, so I guess overall
If you
we
don't
have
have a
addressed
graphic
all.
calculator, you can use a scientific one also for the diagnostic or scholarship test. You can get sample papers for SAT on Khan Academy. Late dates for SAT scholarship test. No, SAT scholarship test would only be done on 30th and 31st of January. That's it. I think I've addressed most of the questions here. The rest are repetitive.
Yes, sir. Yes, sir. Okay. Thanks a lot for the session, sir.
All right,
We got to
guys, stay tuned, and we have the next session starting at 3 o'clock. Thank you so
yes,
much.
see you everyone in the next session. Thank you.
Certainly. Thank you. Bye-bye.